So I used a couple of household products, taped, well, not taped, but put them all together with a mason jar to make an electrolytic hydrogen converter. It converts water and sodium chloride into hydrogen gas and oxygen and several other byproducts. I've heard it makes chlorine gas, probably from the chloride and the sodium chloride in the water. Not quite sure if it would make chloride gas if it were pure sodium in the water. However, it's sodium chloride table salt. The terminals here, you can see one is positive and one is negative. From this old Buick, they never die. One is positive and one is negative. The negative terminal seems to be the one that makes all of the gaseous byproducts, and you can see the one has the bubbles and the other doesn't. I don't have it running right now, but I imagine most of the gases were reabsorbed. It breaks the hydrogen and the oxygen apart, and dihydrogen chloride. Dihydrogen oxygen, water. So you get two H's and an O. You leave them sitting there long enough, I'm sure they'll recombine. I'm trying to figure out how to extract the gases from one syringe, but not from the other because it's not making any. Another byproduct of this is a really interesting byproduct. This is cupric chloride. You can see it's kind of got like a blue color to it. So the bottom layer, blue layer, is it's got a hydrogen molecule, cupric chloride, dihydrogen, I believe. Cupric chloride dihydrogen. The other one does not have a hydrogen molecule, it's one on the top. It's also cupric chloride, missing the hydrogen molecule. It's interesting. One is brown like a penny and the other is kind of like blue, like the Statue of Liberty. And also it's stealing the hydrogen gas out of my little concoction here. I had thought about replacing the wire, changing the metal so that it doesn't have this as a nasty byproduct, but I'm sure, you can make the same reaction for aluminum. It would have you can make deodorant out of this thing if you used an aluminum wire. That aluminum chloride, I believe it is. Yeah, aluminum chloride. So, yeah, and then I'm just gonna plug it in here. I've done this a couple of times. The first time the pressure in the gas, because I didn't have a relief valve, blew the top off 10 feet high, but now I have a gas release valve. Probably not big enough, so I'm not gonna do this for very long. You can see the creation of bubbles, but it only happens in the one terminal. It only happens in the negative and not the positive, which makes sense because it is electricity doing that. That's moving pretty fast. A lot of electricity. I don't recommend doing this on your house on the electrical current because it's 120 volts, whereas this is 10% of this 12 volts. 120 or 240, God, I wouldn't do this on a 240 unless you were an industrial expert. But you see the creation of many, many, many bubbles in one syringe, not the other. I think the movement is an illusion with the light. Okay. Yeah, all the air bubbles are in the negative and not the positive. Now that is the electron, for electricity. I guess that's it. There are several uses for this. It does absorb quite a bit of electricity for the amount of hydrogen gas that it makes. That would probably barely light on fire. A couple more seconds, and if I would have collected it, it would have lit on fire. But, yep, that's it. Simple as that. There we go. It's really wasting my wire, but now I'm making a ton of hydrogen gas because I've got it capped off. Attach this syringe to it.